Alright, and then the last thing I get to do is try to determine where my vertical asymptotes are of each function. So vertical asymptotes of a graph are y equals f of x if either the limit of x approaching a of f of x is positive infinity or negative infinity, or the limit as x approaches a from the, I guess, left or right, doesn't really matter, approaches positive or negative infinity. It's the same thing twice. This occurs when the value of x gives us 0 in the denominator, but not the numerator. Because if it gives me it in the numerator as well, then it is a whole. Alright, so, and if it's just in the numerator, it's just gonna give me 0. I can have 0 on the top, that's fine. That's the other issue. Alright, infinity is not a number, and if the limit fails to exist in both cases, if this seems confusing, then using the notation as x approaches a from the right and the left as the function, as f of x approaches negative and positive infinity. Alright, so find the vertical asymptotes of each function and describe the function's behavior as x approaches from the left and the right of each asymptote. So the first thing I'm going to do, looking at this function, I've got f of x is equal to x squared minus 1. I'm going to factor the top, factor the bottom to see if I have an asymptote or a whole. So factoring the top, I get x minus 1, x plus 1, all over 2 times x plus 2. Alright, I don't have the same thing up top or on bottom. So I just say, okay, my vertical asymptote is going to be where x plus 2 is equal to 0, because that's what's on the denominator. I don't want that denominator to be 0. Dealing with the x. Alright, so x cannot equal negative 2, so I have a vertical asymptote at negative 2. Alright. So now, to try to decide what my behavior as it approaches negative 2 looks like, I can draw a graph, or we can go back in the day and, look at something called sign charts. So sign charts we talked briefly about last year. I'm not going to say that we talked about them very, very, very in-depth, but we definitely did talk about them. You want to put all your critical values on that number line. So that does involve the factors up top and the factors on bottom. What's going to make each piece of that equal 0, no matter if it's in the top or in the bottom. So plugging in like negative 3, for example, just picking some number over here. Plugging in negative 3 would give me a negative number in that factor, a negative number in that factor, all over a negative. So negative times a negative is going to give me positive, divided by negative again. So all in all, over here is going to be negative. Alright, plugging in, let's say negative 1.5 into the top factors would give me a negative and a negative, all over a positive, which all in all will give me a positive. Alright. Plugging in, let's say 0 should give me a negative, a positive, over a positive, and then plugging in, for example, 2 should give me a positive, and a positive, all being positive. Oops, I forgot to put my all in all being a negative. Alright, so all I did was pick numbers that are in between these values, and I literally went and plugged it into each factor individually. That's how I'm getting all of these signs. I don't care about the actual number themselves. I just literally give a crap if it's, negative or positive. That's all I care about. Alright, so now I'm going to look and see what's happening as I am approaching negative 2. And these other critical values will come up later, but for right now they're not too important, but I would definitely keep them in mind, is what I will say. Alright, so as I'm approaching 2 from the left, well, 2 from the left, that's negative. So my limit as x approaches negative 2 from the left is going to be negative infinity. Alright. And then my limit as I approach negative 2 from the right is going to be positive infinity. Should be positive infinity. Oops, forgot to put my little plus sign. Alright, and that's it for that one. Alright, moving on. Next one, I'm going to factor first, and I'm going to get 1 minus x over 2x plus 1 times the quantity of x minus 3. Alright, nothing cancels, so again, I don't have any holes this time around. I do have two vertical asymptotes. One of them being at x equals negative 1/2, and the other one at x equals 3. Alright, so my critical values this time that I probably need to at least take a look at on my sign chart are going to be burp, burp, burp. I'm going to have negative 1/2, 1, and 3. And yes, that 1 is included because it's in the top again. Alright, so plugging in something less than negative 1/2 should actually give me a positive up top all over 2 negatives. Alright, so all in all, that should be positive there. Negative 1/2 and 1, so plugging in 0 just because it's the easiest number to plug in. Should give me a positive over positive and negative, so that whole piece is going to be negative. Plugging in, for example, 2 because it's in between 1 and 3 should give me negative over positive over negative. So that whole piece is going to be positive. And then finally, I'm going to have a negative over plugging in 5 or something like that. Positive and a positive. So negative divided by 2 positive should give me a negative answer overall. So now I've got a whole bunch of limits. I am going to make that just slightly smaller. Throw that up there for a second. Yeah, I can do that. Alright, and I am going to say, okay, the limit as x approaches negative 1/2 from the right, the limit as x approaches negative 1/2 from the left of, that's h of x this time around. Alright, so as I'm approaching it from the right should be negative infinity. And then from the left should be positive infinity. Because it's positive over here. Alright, and then my other asymptote I gotta worry about, the limit as x approaches 3 from the right, and the limit of x approaches 3 from the left of h of x again. Alright, so 3 from the right should be negative infinity. And the limit as x approaches 3 from the left should be positive infinity. And that's about all I gotta do for that one. Alright, keep on stepping. Let's go to the last one. So the first thing I'm going to do again is factor the top, factor the bottom. So I should get x minus 2 over 3x and an x. It's going to be a 2 and a 1. Should be a 1 and a 2. Yeah. Positive, negative. Yeah. So this time I see I might have 2 vertical asymptotes, but that top and that bottom match, which means eat and delete that, so it's not going to be part of my vertical asymptote list because it's the same up top as it is in the bottom once we factored it. Alright, so my only vertical asymptote that I have this time around is just that 3x plus 1. Set that equal to 0, you should get x is equal to negative 1/3. Alright, so really when I make this number line, I'm going to just have negative 1/3. Oops, not negative 13. So plugging in a number on the right, I would get, I'll plug in 0. Just, it's the easiest number to plug in. I get a negative up top and a negative on bottom, so all in all that's positive. And then plugging in an even more negative number than negative 1/3, for example, negative 1, should get me a negative up top over Oh geez, -1, so that'd give me 3. Plugging in -1 should get me positive on the bottom. Not that I just did that. Brain fart moment, it's alright. Forgot to change my signs for a second. Alright, so all in all that's negative. So the limit as x approaches -1/3 from the left should be -infinity. And then the limit as x approaches -1/3 from the right should be positive infinity. Alright, so again, there was a hole at +2. So this time I did not need to worry about plugging in that 2 because it's going to delete itself anyway. It's going to approach the same number anyway, so there's really no point in having it on the sign chart. If we accidentally put it on our sign charts because it's like, yeah, let's just put all the values, that's fine, but it's going to be like 2 positive values right next to each other, so it kind of ends up being a waste of time. But you do you, boo. Have a great rest of your day. See you later.